Before we start example 3, let's take a look at the stuff that's right before it. From geometry, you know that the measures of two sides and a non-included angle, which is your side-side angle, do not necessarily define a unique triangle. Consider the angle and side measures given in the figures below. So if you take a look at these two triangles, given two sides and an angle, we have two different triangles. This is 2 inches, this is 1 inch, and our inside angle is 30 degrees. Where the same thing happens here, this is 2 inches, this is 1 inch, and our inside angle is 30 degrees, but you can tell angle B is not going to be the same in these two triangles. So we could have different triangles, different number of triangles, depending on what side lengths and angles were given. We call this the ambiguous case of the law of sines, and it only happens when you have a side-side angle triangle. In general, given the measures of two sides and a non-included angle, one of the following will be true. Either 1, no triangle will exist, 2, exactly one triangle exists, or choice 3, 2 triangles exist. And we'll go over an example of each one of these situations. When solving triangles for this ambiguous case, there may be no solution, 1 solution, or 2 solutions. So let's take a look at example 3. Example 3 is the ambiguous case that gives us 1 solution. So this is a case that we have side-side angle and only 1 solution. It says find all solutions for the given triangle if possible. If no solution exists, write no solution. Round side lengths to the nearest tenth and angle measures to the nearest degree. We're going to start by creating or drawing our triangle out. So let's do that. So here's A, B, and C. And angle A is 94 degrees. Little a is 15. Little c is 12. Oops. Let's try that again. All right, and we're going to use that information to find what we need. So the first thing we have to do is we have to find one of our other angles in order to use the law of sines. So we can either find angle B or angle C. Well, since we don't have side length little b, we don't have enough information to find B. So the first thing we have to do is we have to find angle C since we have that side, and then we can use angle A and side A to help us along. So the first thing we're going to do is we're going to find angle C. To do that, using the law of sines, using A and angle A, we would have the sine of 94 degrees over 15 equal to the sine of C over 12. If we cross multiply, we get 12 times the sine of 94 degrees equal to 15 times the sine of C. Again, we're looking to get C by itself. Right now it's attached to that sine. So my next thing to do is divide both sides by 15. And I get 12 times the sine of 94 degrees over 15 equal to the sine of C. And since I need C, I need to use my inverse function. So I'm going to take the sine inverse of all that stuff, 12 sine of 94 degrees over 15, and that's going to give me C. So take a second now, pause it if you need to, and plug this whole thing into your calculator to make sure your answer matches up with the answer I'm going to give you. Rounding to the nearest degree, if you plug this in correctly, you should get 53 degrees. So I'm going to plug that into write that down in my triangle. This is 53 degrees. And then the next thing I'm going to do is I'm going to go ahead and find angle B, because angle B, if I have my other two angles, angle B is pretty easy to find by just subtracting from 180. So the measure of angle B is going to be 180 minus 94 minus 53. So angle B is going to be 33 degrees. I'll fill that into my triangle. And then we need to find our last thing, which is side B. So now we're going to go ahead and find side B. So find little b. And to find little b, we can use angle A and side A. So the sine of 94 degrees over 15 equal to the sine of 33 degrees, which is our angle B, over little b, which is what we're trying to find. And then if we cross multiply, we have b times the sine of 94 degrees equal to 15 times the sine of 33 degrees. And then we'll just divide both sides by the sine of 94 degrees. Again, try that on your calculator, see if your answer matches up. If it does, you should get b to be approximately 8.2. So we have C 53 degrees, angle B 33 degrees. Here, let's make this is angle C, and then B is 8.2. Then what we need to do is we need to decide, do we have a third triangle or not? And to do that, we need to take a look that there are two angles between 0 and 180 degrees where the sine of that angle is going to be the same positive answer. So we need to take that 180 degrees and subtract our original angle, which was 53 degrees. And we would get 127 degrees as our angle C. Then we have to think to ourselves, if we take 127 and add it to 94, can we get another angle to equal 180? And the answer to that is no, because 127 and 94 is already 221, and it's bigger than the angles, the sum of the angles of a triangle. So this tells us here that we do not have a second triangle. So we are done with this one. There's only one answer, and that is angle C, 53 degrees, angle B, 33 degrees, and side B, 8.2. Next, I'd like you to do the try this. So you can pause it now, unpause it when you're ready to check your answer. If you did the try this correctly, you should get angle C to equal 1 degree. Angle B is equal to 149 degrees. And side B is approximately 13.4. Let me know if you have any questions.